let's discuss example 1, where in this example, we have a combination between lever and also mass. The input to the system is xi, and the output to the system is x0. Here we can see that we have two body. The first one is mass, and the second one is the lever system. So we're going to do the analysis on both systems. So let's consider the mass first. Going to do the FBD on mass. So we're going to draw the mass here. So there will be the force acting on the mass due to the spring, and it will cause the mass to move to that direction. So we know this force is due to the spring. So we write Fs1. So let's do the analysis on the spring. Here we know that the lever will also have a displacement of xb, and here we have also a displacement of xa. So for spring number 1, let's consider xb is bigger than x0. So if we consider that, we know that the spring will be in compression. The reaction for the compression is that the spring will push back. This is the reaction. So the reaction from the spring is to push back. Okay, so therefore the force here is in this direction. So we can write the equation for mass system. So we say that, okay, if here is positive, then we say that Fs1 is equal to md square theta naught. The second element that we're going to do the analysis is on the lever system. So we draw the lever system. The lever will displace by XA, and also we have a displacement to this side by XB. Then in terms of force due to the spring, we have a force from spring number 2. So we write Fs2. Then we have another force for spring number 1, Fs1. For spring number 1, we know that the direction will be to this side. Then to determine the direction for spring number 2, the force for spring number 2, we need to do the analysis. So let's consider xi is bigger than x. So we consider xi is bigger because xi is the input. So if xi is bigger than xa, therefore the spring will be in tension. For the reaction is that it will try to pull it back. At this position, the direction will be to this side. So let's write the equation for the lever system. So in terms of force, the equation will be Fs2 over Fs1 is equal to B over A. Then in terms of displacement, XA over XB is equal to A over B. So this is the first equation, this is the second equation, and this is the third equation. Then next, we write the equation for spring 1 and spring 2. Fs1 is equal to K1 XB minus X0. Then for Fs2, the equation is K2 Xi minus Xa. Okay, next, let's draw the block diagram. The input is the X0, and I will use equation number 1. So from equation 1, X0 is 1 over md square, and the input is Fs1. Okay, so I have used this equation. Okay, for Fs1, I'm going to use equation number 4. So Fs1 is K1, and the input is Xb minus X0. So we know we can draw a summation point. Okay, the input will be Xb, and we can tap from X0 to this here. So this is plus, this is minus. Okay, then we're going to solve for XB. We can use equation number 3. Okay, because in equation number 3, there is XB term here. So from there, XB will become B over A. The input is XA. So now we're going to solve for XA. So XA, I'm going to use equation number 5 because in equation number 5 we have XA here. So therefore we need to rewrite XA. XA is equal to XI minus FS2 divided by K2. So meaning for XA, we're going to draw a summation point with two arrows. So this is XI plus minus FS2 divided by K2. So now we're going to use for this part here. So FS2 is multiply with 1 over K2. Okay, here is FS2. So now we're going to solve for FS2. So the last equation that we haven't used is equation number 2. So from equation number 2, can draw B over A multiply with FS1. So just step from FS1. So from there, we get a complete block diagram.